Hi, my name is Sean Sterling and I'm with Geopharma Engineering. Today I'm going to present the borehole drilling and testing program that's planned in Southwestern Ontario near Teeswater as part of the Nuclear Waste Management Organization's Deep Geologic Repository site characterization work. This is a fairly large project and there's obviously a lot of people to give credit to. My co-author on this is Martin Sykes from the Nuclear Waste Management Organization, who is the project manager for NWMO. As well as Martin, there's a lot of people at NWMO and Geopharma that are also helping out. The Nuclear Waste Management Organization has a program called the APM project, and it's the Adaptive Phase Management project. I'll go over the background of that. I'll also be giving an overview of the characterization work that we have planned, as well as recent progress and where we're heading. The Nuclear Waste Management Organization was established in 2002 and is funded by Canada's nuclear power producers. The fuel used in Canada's nuclear reactors, after it is expended, is stored in water pools, followed by dry storage above ground at each nuclear facility. NWMO chose the Adaptive Phase Management Plan in 2007 as the path forward to deal with Canada's used nuclear fuel. Between 2010 and 2012, the NWMO asked which communities would be interested in hosting such a facility. In total, 22 municipalities and Indigenous communities came forward by 2012. Since 2010, the NWMO has completed initial screenings, preliminary desktop studies, and is currently completing field investigations. Currently, there's two communities that remain in the process, Ignace, Ontario, and South Bruce, Ontario. And today's presentation will focus on the drilling and testing activities planned for South Bruce, Ontario. Geopharma is contracted by NWMO to complete the borehole drilling and testing program. And it's approximately a 3-year study that was started last year and includes 2 boreholes, approximately 2 kilometers apart near the community of Teeswater, Ontario. The work itself includes 13 technical work packages. The main field-based packages include local water well testing and background evaluations, and site construction, both of which have been started in the fall of 2020 and are primarily completed at this time. And then starting in April 2021, the drilling and testing program begins, which will include continuous coring, core logging and photography, sample collection and laboratory analysis, borehole geophysics, hydraulic testing, opportunistic groundwater sampling, which is essentially collecting groundwater samples during drilling, temporary borehole sealing, and long-term monitoring using a WestPay MPA55 system. Southern Ontario is a sedimentary bedrock basin, and the site is actually located about 30 kilometers east of Lake Huron in the municipality of South Bruce. The Michigan Basin itself is over 500 kilometers in diameter, and you can see here that the sedimentary bedrock units that form the basin are continuous, conceptualized as continuous underneath Lake Huron and into Michigan itself. The borehole that we're going to be drilling is shown here on the right-hand side in South Bruce, and it's going to be approximately 900 meters deep, and it's going to extend through all the Ordovician bedrock formations and terminate just above or just into the Precambrian bedrock. This figure just shows a generalized schematic of the sedimentary bedrock sequences that we expect to drill through at the South Bruce site. There's approximately 35 distinct bedrock units in the 900 meters of sedimentary bedrock above the Precambrian basement. These units are fairly well defined through oil and gas drilling and other borehole logs, as well as the drilling that occurred at the Bruce nuclear site between 2006 and 2010. Before drilling and testing activities, information was gathered to determine pre-drilling conditions, which included testing local water wells, the baseline soil sampling of the drill pad itself, as well as noise, vibration, and air quality monitoring. All of this information is collected to help determine if there is any impact due to the drilling and testing program on the neighboring environment. Each of the proposed drilling locations is located in an existing agricultural field, and a small access road was built and a drill pad was constructed at each location. In addition, hydro was taken from the nearby county road to the site, which will be quite useful in that we won't need to be operating the site on generators. The borehole drilling program is planned in 4 stages. Stage 1 involves surface casing down to bedrock. Stage 2 installs a second casing down to a depth of approximately 65 meters. And this is to ensure that saltwater conditions below this depth do not interfere with the local water supply wells. Stage 3 involves coring down to a depth of approximately 180 meters and installation of a steel surface casing. And this again is to prevent any upward migration of brine conditions to interfere with saltwater. And the 4th stage is a continuously cored hole from this depth of about 180 meters down to the total depth of borehole at around 900 meters. And this will be the main part of the borehole for testing. All of these drilling stages will include blowout prevention equipment in accordance with the Ministry of Natural Resources and Forestry regulations. The borehole drilling program involves a lot of different equipment, including 4 or 5 trailers, which includes office trailers, core logging trailer, and a laboratory trailer, as well as the drilling equipment itself, the rig, the mud cleaning system. And so it takes a fairly large footprint. The drilling site itself is approximately 50 meters wide by 100 meters long to give enough room for the equipment. Like I mentioned before, the drilling itself will include blowout prevention. The picture in the top right-hand corner shows a blowout preventer. And the type of rig that is planned to be used for this work is similar to the one in the top left-hand corner, which is a diamond coring rig, but it's been adapted to use the oil and gas blowout prevention equipment. The drilling program will be centered around wireline coring equipment using a PQ3 coring bit to produce an approximately 83 millimeter diameter core and 123 millimeter diameter borehole. The drilling fluid itself will be a 2-fluid system with fresh water primarily being used above 170 meters and below 170 meters a brine-based drilling fluid. The drilling fluid itself will use fresh water taken from Lake Huron and mixed on site with sodium chloride or calcium chloride to a desired brine concentration. In addition, a fluorescent green dye, sodium fluorescein, will be used in the drilling fluid itself, and this will be useful in later stages to determine drill fluid impact on groundwater chemistry and pore water results. Drilling activities themselves will have a big impact on the in situ groundwater conditions, and groundwater samples will be targeted during drilling in an attempt to collect a groundwater sample that best represents those in situ conditions before drilling activities. When we reach a desired depth with expected permeability, coring will stop, the drill rods will be pulled back, and an inflatable packer will be lowered to isolate the zone at the bottom of the borehole. The drilling rods will then be purged with swabbing gear, and the water that comes out during the purge water will be monitored on site for sodium fluorescein to determine when a representative groundwater sample is ready for collection. During drilling, continuous core will be collected and brought up to surface in 3-meter sections. Each core will be taken to a core logging trailer where it will be photographed, logged for stratigraphy and geotechnical properties, and select samples will be identified for preservation. Each sample will be sealed in 2 layers of polyethylene as well as an aluminum foil, and it'll be nitrogen flushed and vacuum sealed for preservation. Those samples then will be sent off to various laboratories for analysis. In total, about 400 rock core samples are targeted for preservation and testing, including geomechanical testing, pore water chemistry, mineralogy, and organic geochemistry. After continuous coring each section of the borehole, and before steel casing is installed, borehole geophysical logs will be completed over the open borehole interval. This will provide information on borehole size and shape, as well as bedrock properties, such as porosity and flow characteristics, as well as structural features throughout the borehole. And all of this information will be quite useful in interpreting bedrock conditions and helping out plan hydraulic testing intervals. Following borehole geophysical logging, a custom-made straddle packer testing tool will be used to complete hydraulic testing over the entire borehole length. An interval of approximately 30 meters with a packer on the top and bottom will be used. This tool will also have the ability to be reduced in size down to approximately 5 meters. In total, about 15 tests are planned over the entire borehole length, and this will primarily be from below the Salina F shale, so below the 180 meter mark where the lowermost casing is installed, and the bottom of the borehole. And each of these tests, due to the low permeability of the formations, will be designed as a slug test. And each one of these tests is anticipated to take approximately 2 to 3 days to complete. This information will be very useful in assessing the permeability of the rock, essentially how impermeable the rock is, including the repository horizon and the cap rocks. Following hydraulic testing, each borehole will be completed with a multi-level system, and the multi-level system selected is a West Bay MP55 system, which will be a series of inflatable packers with a pressure monitoring port in between each packer. The multi-level systems designed for these boreholes will have approximately 30 monitoring intervals over the entire open length of the borehole, and each interval will have the ability to measure pressure over time. A select number of these ports will have a dedicated pressure transducer and a data logger associated with it, and some of the low permeability formations will take approximately a year or more to equilibrate after the drilling conditions. While these are some of the first boreholes being drilled and tested in the Teeswater area, considerable work has been done historically in southwestern Ontario in similar bedrock environments. From this work, 3 hydrogeological systems have been conceptualized, and we expect to see those at this site as well, which include a shallow hydrogeological system above the Salina F shale, or about 175 meters below ground surface. Includes some permeable bedrock formations, primarily advective groundwater flow, fresh to brackish water. Below this and down to about 400 meters, permeability decreases, saline to brine conditions with advective and diffusive transport. And below 400 meters is primarily conceptualized as an aquiclude system with very low permeability, down to the order of 10 to the minus 14 or 10 to the minus 16 meters per second, primarily brine conditions and diffusive transport. Just above the Precambrian basement is where the Cambrian sandstone exists further to the west. And whether it exists at this location or not is an outstanding question, as well as what the groundwater pressures are. There has been evidence of flowing artesian conditions from this depth further to the west, and that's an important question to be answered during this drilling. And with that, I thank you for your time and ask if there's any questions.